at Math Engineering Link Class 4 Microprocessor 8085 Architecture. In this video, we see timing diagram of 8085. Opcode fetch, memory read, memory write, I bar O read, I bar O write. And control signals ALE arbitrary logic enable RD read write signal and IO bar M ready signal. AT85 control signals ALE RD WO ready and IO bar M signal is seen in that figure. Then timing diagram of opcode fetch memory read write I bar O read I bar O write signal shown in that figure. Timing diagram of 8085 microprocessors. The time diagram is a graphical representation where the 8085 instruction timing diagram represents the execution time of each instruction in graphical format. In this chapter, we will be going through the timing diagram. We will go through different machine cycles such as opcode fetch, memory read, memory write, I bar O read, and I bar O write. Then we will go through the timing diagram of some instructions such as MVI, STA, and INR. What is a timing diagram? A timing diagram is a graphical representation. The 8085 instruction timing diagram represents the execution time of each instruction in graphical format. Execution time is given in T states. The 8085 microprocessor has a set of control signals and data signals that play an important role in the execution of instructions. In this chapter, I will explain and draw a timing diagram of different instructions, that is clock signal, machine cycle, T-state, and control signals. Clock signals. The time required to execute an instruction is called a clock cycle. Machine cycle. The time required to access memory or input or output devices is called a machine cycle. The 8085 has 5 basic machine cycles, that is load opcode, read from memory, write to memory, read I bar O and write I bar O. T-state. A machine cycle and an instruction cycle takes several clock periods. The portion of an operation performed in one system clock period is called a T-state. Control signals. The control signal controls the operations. Common signals are ALA, read, write, and IO bar M, memory. Machine cycles of 8085. The 8085 microprocessor has 5 basic machine cycles. I already explained. Opcode fetch, memory read, memory write, I bar O read, I bar O write. Opcode fetch is 40 state. At another 4 basic machine cycles with 3 T state. Opcode fetch machine cycle of 8085. Each processor instruction has a 1 byte opcode. Operation codes are stored in memory, thus the processor performs an opcode load machine cycle to load the opcode from memory. Thus each instruction begins with a machine cycle of opcodes. The time the processor takes to perform an opcode load cycle is 40. That is important point. At this time, the first 3 T states are used to load the opcode from memory, and the remaining T states are used for internal opcodes. That is noted. Kindly noted that point. Next page we see timing diagram of 8085 microprocessor, that is opcode fetch cycle diagram. That is 4 states. That is 4 T states. T1, T2, T3, T4. RD read signal, that I bar M signal, AD7 to AD0, ALE, A15 to AD, that is clock signal. That is shown in figure. 4 stages. Memory read machine cycle of 8085. A memory read machine cycle is executed by the processor to read a data byte from memory. The processor takes 3D states to perform this cycle. Instructions that have more than 1 byte word will use machine cycle after machine cycle to load the opcode. That is 3D states. That is an important point. Next stage we will see the cycle diagram. That is 3 states. T1, T2, T3, and odd is read signal I, O, bar, M, ALE, or address buffer. Then in this diagram we see memory write machine cycle of 8085. A write to memory machine cycle is executed by the processor to write a data byte to memory. The processor takes 3D states to perform this cycle. That is an important point. Instructions that have more than one byte word will use machine cycle after machine cycle to load the opcode. The diagram shown in that page, 3 stages. I bar O read machine cycles. A read and I bar O cycle is performed by the processor to read a data byte from an I bar O port or peripheral that is I bar O mapped in this system. The processor needs 3D states to execute this machine cycles. That is 3D states is important points T1, T2 and T3 shown in figure. I bar O write machine cycle. Writer's I bar O cycle is executed by the processors to write a data byte to an I bar O port or peripheral that is I bar O mapped in the system. The processor needs 3D states to execute this machine cycle. That is T1, T2, T3, 3 states cycle. That is noted. Timing diagram of some instructions MVIA, 45. STA 8000H, IN or M. That is very important instructions. Timing diagram of MVIA, 45. Loading opcode 4EH from memory 2000H. That is operation code loading machine cycle. Read move data 45H from memory 2001H, memory reading. Tabulation shown in that page. Address mnemonics opcode. That mnemonics instructions is very important. Diagram, timing diagram of 885 microprocessor shown in figure. That is first 4 stages and second 3 stages shown in figure. Timing diagram of a STA 8000H. STA stands for store accumulated. The contents of the accumulator are stored at 1000H. The transaction code of STA indicates 32H. It is provided by 1000H memory. See in the picture. In the machine cycle, then read the sub address 00. Memory reading machine cycle. Read higher memory locations 80. Memory read machine cycle. Consider the combination of the two addresses and write the details of the accumulator for 8000. Don't forget to write the machine cycle. Assume the memory address for the instruction and let the content of accumulator as C7H. So C7H from accumulator is now stored in 8000H. Tabulation is shown in figure. Mnemonics is STA 8000H. Opcode 32H, 00H, 80H. Timing diagram of STA instruction that is shown in figure. First 4 stages and first 3 stages and again 3 stages and last 3 stages. Timing diagram of INR M instructions. C500H, INR M34H. D050 as memory address, E1H and E2H as opcode. That is timing diagram of I increment instruction. That is INR instruction. Applications of 8085. System charts keep track of all changes occurring in the system. Timelines provide a more accurate representation of physical activity. The timing table of 8085 instructions graphically represents the time required to execute each instruction. Timing diagram is a special form of sequence diagram. Timing diagram keep track of every change that occur in the system. The timing diagram is important for planning the clock frequency of the microprocessor. The timing diagram helps design memory circuits that meet the required set and hold times during read and write operations. At Man and Thank you.